Why do human spacecraft never fly directly above or below the solar system? Do you think it's because there's nothing there? Wrong. It's not that we don't want to go there. We simply can't. You might say, come on, that's nonsense. Humanity has sent probes to every planet in the solar system. We have rovers driving around on Mars. We even flew past Pluto, 3.5 billion miles away, capturing stunning close-up images from less than 13,000 kilometers away. So why not just point a rocket straight up and fly above the solar system? That's the most counterintuitive part. The laws of physics don't make it that simple. In fact, ever since the dawn of spaceflight, humanity has been trapped inside what is essentially a giant, flat, cosmic prison. Today, we'll explore why escaping vertically from the plane of the solar system is up to 7 times harder than reaching Pluto, what a spacecraft might actually see if it managed to get there, and whether the surprisingly wild solutions scientists have proposed could ever work. But before we can understand why flying up is so difficult, we first need to understand one important thing. Right now, you're not standing still at all. The Earth beneath your feet is racing around the sun at nearly 30 kilometers per second, about 100 times faster than a bullet. Every time you blink, our planet has already traveled about 30 kilometers sideways through space. And here's the important part. Every rocket we launch automatically inherits that speed the moment it leaves Earth. Whether it's a Chinese Long March rocket or a NASA space probe, none of them start from zero. The instant they reach space, they're already moving sideways at around 30 kilometers per second around the sun. This speed is basically a free cosmic cheat code. To reach Mars, a spacecraft doesn't need to accelerate from scratch. It only needs to add a few more kilometers per second to its existing motion, and it can drift toward the red planet. For most missions, Earth has already done most of the hard work for us. But what if you wanted to fly directly above or below the solar system? That's where this free advantage suddenly becomes a wall you can't simply break through. To travel straight up, you'd first have to completely cancel out that built-in 30 kilometers per second of sideways motion. Only after eliminating it could you start gaining new velocity in the vertical direction and climb out of the solar system's planetary plane. The amount of energy required is absolutely staggering. Aerospace engineers measure mission difficulty using something called delta V, or the amount of velocity change a spacecraft needs. Reaching Mars from Earth's orbit requires roughly 4 kilometers per second of additional speed. Escaping vertically out of the solar system's planetary plane requires about 30 kilometers per second. That's 7.5 times more. Over the past 4.6 billion years, Earth has built up an enormous amount of orbital momentum, and that momentum effectively traps us inside this flat cosmic disk. We can travel around the sun with ease. We can hop from one planet to another within this giant celestial platter. But the moment we try to leave the platter itself, we have to fight against 4.6 billion years of accumulated inertia all at once. It's one of the most counterintuitive facts in orbital mechanics. Flying 3.5 billion miles to Pluto can require far less fuel than traveling a few million kilometers directly above the sun. Because the cost is so extreme, very few spacecraft have ever ventured into those regions. As a result, even in 2026, the space just 1 million kilometers above the sun's poles remains more mysterious to us than some of the most distant regions we routinely study. We have global high-resolution maps of Mars. We have close-up images of Pluto's frozen plains. We can photograph Jupiter's moons in remarkable detail. Yet the sun, the closest star to Earth, has kept one of its biggest secrets hidden from us. Its north and south poles are places we have barely seen at all. What's even more surprising is that the source of the solar storms capable of disrupting Earth's power grids lies near the sun's poles. The fastest solar winds erupt from these regions, and the sun's magnetic field reversal, an event that happens every 11 years, also begins there. In a sense, the weather of the entire solar system is controlled by 2 places we've barely been able to see. For decades, we could only observe the sun from the side. Imagine trying to understand Earth's climate while spending your entire life standing on the equator. You'd never witness the Arctic blizzards or the mysteries of Antarctica. In human history, only 2 missions have truly glimpsed the sun's poles. The first was the Ulysses spacecraft. To tilt its orbit by nearly 80 degrees, it took a massive detour, traveling over 1 billion kilometers, equivalent to circling Earth about 250,000 times, just to get a sideways look at the poles. But its 1980s instruments included no camera, so it could only measure solar wind, magnetic fields, and charged particles. The second is the Solar Orbiter, which spent years using repeated gravity assists from Venus to slowly tilt its orbit and reveal views of the Sun that humanity had never seen before. By slowly tilting its orbit over many years, the Solar Orbiter finally achieved what no spacecraft had done before. In March 2025, it sent back humanity's first direct images of the Sun's south pole. What scientists saw was astonishing: a chaotic tangle of magnetic fields, completely different from the smooth, familiar face of the Sun we see from Earth. It was like discovering an entirely new world, hidden in plain sight. Think about that. Until just recently, humanity had never truly seen what the Sun's poles looked like. But there's an even bigger reason why traveling above the solar system matters. We still don't know exactly what our solar system looks like from the outside. Surrounding the Sun is a giant bubble called the heliosphere. Created by the solar wind, it acts as a protective shield, deflecting dangerous cosmic radiation and safeguarding everything inside, including Earth. Beyond this bubble lies true interstellar space. For decades, textbooks showed the heliosphere as a comet-shaped structure, with a rounded front and a long tail stretching behind it. It was a reasonable guess based on the limited data available at the time. Then, in 2020, scientists at Boston University reanalyzed new NASA data, and what they found suggested that our picture of the solar system's protective bubble might be far more surprising than anyone had imagined. Then came a surprise that changed everything. Using new NASA data, scientists proposed that the heliosphere, the giant bubble surrounding our solar system, may not look like a comet at all. Instead, it could resemble a flattened croissant with a bulging center and two short jets extending from either side, but no long tail. Why has this debate lasted for decades? Because we've spent 4.6 billion years living inside this bubble without ever seeing its true shape. The Voyager probes are like ants crawling out through a tiny crack in a fish tank. They can glimpse a small piece of the glass, but they can't tell whether the tank is round, square, or something else entirely. To truly understand the shape of our solar system's protective bubble and our place in the Milky Way, there's only one option: leave the planetary plane and look down from above. But how do you do that? Build a bigger rocket? Unfortunately, that won't work. The energy required to cancel Earth's enormous sideways motion is so extreme that no practical rocket can carry enough fuel. After decades of searching for answers, aerospace engineers came up with a solution that sounds completely backwards. To fly upward out of the solar system, you may first have to fall toward the Sun. The idea is called the Oberth maneuver, and it turns everything you think you know about space travel upside down. Instead of pointing your engines upward and fighting your way out of the solar system, you do the exact opposite. First, you let the spacecraft fall toward the Sun. As it dives deeper into the Sun's gravity well, it accelerates faster and faster. By the time it reaches its closest approach, its speed can exceed 100 kilometers per second, faster than any bullet, faster than almost anything humanity has ever built. Then comes the crucial moment. At the precise instant when the spacecraft is moving at its maximum speed, the engines ignite. Why? Because in 1929, rocket pioneer Hermann Oberth discovered a remarkable principle. A rocket burn becomes dramatically more effective when performed at the point of highest velocity inside a strong gravitational field. Imagine riding a bicycle up a steep hill. Starting from the bottom and pedaling uphill from a standstill is exhausting. But if you first roll down the opposite side, build up tremendous speed, and then push hard at the lowest point, you can shoot up the hill with far less effort. The Oberth maneuver works the same way. First, fall toward the Sun. Let gravity do the hard work. Build up incredible speed. Then, at exactly the right moment, fire the engines and use that speed to launch yourself out of the solar system's flat plane and into territory no spacecraft has ever truly explored. So how do we finally escape the solar system's flat prison? One idea is to dive toward the Sun and use the powerful Oberth maneuver. At the moment of maximum speed, a spacecraft fires its engines and gains enough energy to shoot upward out of the planetary plane. Another approach is even more elegant: a solar sail. Imagine a giant, ultra-thin mirror floating through space. Sunlight itself pushes on the sail, not with wind, but with countless photons. The force is tiny, yet continuous. Over years, it can slowly tilt a spacecraft's orbit higher and higher without using a single drop of fuel. The most promising mission design combines both methods. First, a solar sail spirals inward toward the Sun. Then, Near the closest approach, the spacecraft performs a powerful Oberth burn, launching itself into a steep orbit above the solar system. If humanity succeeds, we'll finally see our cosmic neighborhood from a completely new perspective, and the first surprise may be how clean space looks from above. From Earth, we're buried inside the solar system's dusty disk. Countless grains of dust, asteroids, and debris orbit within this crowded plain. But high above it, the view could be astonishingly clear, a pristine panorama of the sun, the planets, and the vast darkness beyond, seen from an angle no human-made spacecraft has ever truly explored. Imagine leaving the solar system's crowded planetary plane behind. Down here, space isn't as empty as it seems. It's filled with dust from ancient collisions between comets and asteroids. That dust creates the faint zodiacal light sometimes visible in dark skies on Earth. But climb high enough above the solar system, and the haze disappears completely. Suddenly, you're in one of the cleanest observing locations imaginable. No scattered dust, no background glow, just a crystal clear view of the universe. Telescopes here could detect faint signals hidden from Earth, search for signs of life around distant planets, and study the ancient light left behind by the Big Bang. The sun would look different too. Near its equator, the solar wind is turbulent and chaotic, but above the poles, powerful streams of fast solar wind shoot into space at hundreds of kilometers per second, forming enormous, stable rivers of charged particles flowing into the galaxy. And then comes the most extraordinary sight of all. For the first time, you'd see the solar system from the outside looking in. The planets would no longer form a line across the sky. Instead, they'd appear as tiny worlds circling a brilliant star at the center of a vast cosmic disk. After centuries of exploring our celestial neighborhood from within, humanity would finally see its true home from above, and perhaps understand our place in the universe in a completely new way. From high above the solar system, all the planets would appear as a thin, glowing disk orbiting the sun. Dust would hug the plane, and the heliosphere would surround everything like a giant protective bubble. The incredible truth is that humanity has never taken a photo like this, but one day we might. And when that first true family portrait of our solar system finally arrives on Earth, you may look up at the sun and realize something astonishing. For all our exploration, all our spacecraft, and all our discoveries, we've only just stepped outside the front door of our cosmic home. See you in the next journey through the universe.